Hi everyone, welcome and thank you for joining us. My name is Liz Garcia and I am your moderator for today's event. We have about 50 minutes of great content prepared for you with 10 minutes for questions at the end. Before we get started, I wanted to go over a few housekeeping items. You have complete control over your console. You can minimize, maximize, or change the size of your widget at any time. We encourage you to ask questions throughout the presentation. Your lines are muted, so please submit all questions using the Q&A icon, and we will answer them at the end of this presentation. If we do not address your question, we will respond to it via email after the event. Use the document link for some helpful resources on security resilience. And later this week, we will send you the PowerPoint slides, event recording, and the white paper that this presentation was based on. If you need technical help with the presentation, please press the question mark icon. And we always appreciate feedback. So please take the survey using that clipboard icon before you exit this event. And that's all the announcements we have. So we are ready to go to the next slide and get started. Thank you for joining this webinar, Best Practices for Security Resilience. My name is Liz Garcia, and I am the moderator for this event. Our industry experts, John Olstick, Senior Principal Analyst at ESG, and Keith Bromley, Senior Solutions Marketing Manager at Ixia, a Keysight business, will explain how resilient security goes beyond the traditional defensive approach to your security architecture. Thank you for joining us, John. Can I have you give our audience a little background about yourself?
Sure, it's nice to be here. My name is John Olstick, Senior Principal Analyst and ESG Fellow at the Enterprise Strategy Group. I've been in the IT industry for over 30 years, and I've been in security for about half of that time. I founded ESG's cybersecurity practice in 2003 and have been going at it ever since.
Thank you, John. I've been following you throughout your career. I'm really excited to hear what you have to say today. Keith, can I go ahead and have you introduce yourself as well as share the agenda with our audience?
Sure. Hi, everybody. Keith Bromley, Solutions Marketing Manager right now. Been a marketing manager, product manager, engineer for over 25 years in IT and high-tech solutions, including voice over IP, security, network monitoring, all sorts of good stuff. So thank you for attending the show. I'm looking forward to telling you more about our solutions and network security resilience. Okay, here's the agenda for our discussion today. John is going to start off with a conversation and a quick level set on cybersecurity research that he's conducted and some of the challenges that he had seen. He will also introduce the concept of network resilience. Then I'll come back and talk about some ways that you can make your security architecture more resilient. So let's get started. John, it's over to you now.
Thank you, Keith. And I, too, am going to talk about network security resilience. I noticed I wrote network resilience on my slide, and that's actually appropriate because network resilience includes security. It includes availability and performance. And really, that's the context I think we have to think about with networking today. It's security, but it's uptime and it's performance. That's what our businesses really want us to do. So let me move on to my next slide. Let's start by looking at what organizations have as their network security operations objectives. So this is some research from a recent ESG research project. And the number one thing that people are trying to do is improve their ability to detect, contain, and remediate advanced attacks and insider threats. 34% said that that was important. And that's consistent with what we see from reports like the Verizon Data Breach and Investigations Report, which indicates that a lot of times detection takes over 200 days. And of course, that's unacceptable. We need to really streamline that number. We also see that 29% said that they want to improve their ability to discover, prioritize, and remediate software vulnerabilities. This is something I've been tracking since I started in security. It's complex, it's overwhelming, and it hasn't improved. So it's really, really important that we improve our performance there. I'm going to skip to the bottom of the chart. As you can see, 27% want to decrease the amount of time it takes for security incident detection. Now, we talked about that at the top, but they want to detect faster, they want to remediate faster. Remediation involves security and network operations groups. And 27% want to improve their ability to investigate critical alerts. These have to be prioritized. We have to sort through and filter out those we don't want to investigate. And I'd point people back to the Target breach of a few years ago, where there was an alert, but security operations teams chose to ignore that alert, and it led to, of course, a bad consequence, a data breach. So we have to be sensitive to that. So the question is, how are we doing against these kind of objectives? The research indicates that we're not doing very well. So this is research from last year's ESG report that we did in conjunction with the Information Systems Security Association, ISSA, which is an organization of 11,000 global cybersecurity professionals. Now, to summarize what this slide says, first of all, 53% of those that we surveyed said that their organization had experienced a severe security incident or some type of a data breach over the past 2 years. So that's pretty significant. Some of them have suffered many data breaches or significant incidents. Now, you also see on the right side that 34% of those that we surveyed said that they don't know or prefer not to say. My guess is that they prefer not to say. These are security professionals. They're trained to be skeptical and paranoid, and therefore they weren't willing to participate. But in summary, 53% had suffered some kind of serious security incident or data breach, and many of these organizations have suffered many other types of less serious security incidents. So while we have those objectives that I talked about on my first slide, we're not doing very well. The bad guys are getting through, they're penetrating the network, they're causing damage. So 53% have suffered these security incidents or data breaches. What has that led to? Well, there's a couple of breakdowns here. So at the top of this chart, you see 35% say that the result of these security incidents was lost productivity. So people couldn't do their work. This is the same as any kind of a network disruption, whether it's a man-made or natural disaster. But it impacts the business. And 33% said that it required a significant IT time or personnel needed for remediation. So we had the security incident, we had to throw all our troops at it to fix things that cost us in terms of time and probably things that we wouldn't do. Now that's an IT mindset, but if you look at the two next responses that I highlighted here, 28% said that a security event led to the disruption of a business process. And 23% said the disruption of a business application or IT system availability. So now we're getting into the business consequences. We think about security, we think about cyber adversaries, we think about viruses, and we live in this world. But ultimately, these are IT assets. The IT assets are valuable to the business, and these types of incidents are impacting businesses. They're costing us real money in productivity, downtime. And that's why network resiliency, the ability to recover very quickly from these types of security incidents without this type of business disruption, are why that concept is so important. Now let's look at what were the biggest contributors to these security events. And this again is from our ISSA panel. So 31% said a lack of adequate training for non-technical employees. This makes sense because cyber adversaries are using social engineering techniques. They're using really sophisticated phishing attacks. And non-technical employees, including, and I would say even IT employees, are often fooled by this type of attack. 22% said the cybersecurity team is not large enough for the size of our organization. We have a global phenomenon called the cybersecurity skills shortage, which is pretty acute and pretty profound. And so organizations don't have as many skilled people as they need, and that's impacting our ability to thwart these kinds of attacks. But if I go to those that I highlighted here, 17% said new IT initiatives such as cloud computing, mobile computing, etc., have been implemented without proper cybersecurity oversight and control. Well, IT initiatives are linked to the business, and security has to know what the business wants to do in order to protect it. So there's a disconnect there. Also, a general lack of oversight on cybersecurity risk, 13%. Once again, the business context. The security team has to know what the IT initiatives are, what the business goals are, to be able to protect the assets and guarantee, or at least try to guarantee, that security is, the assets are protected and security is whole. Now, we know these events are happening, and unfortunately, the data can be pretty depressing. So in this survey with the Information Systems Security Association, we asked a pretty fundamental question. We asked these security professionals whether they thought that other organizations, other than their own organizations, or most organizations, were vulnerable to some type of serious or significant cyber attack or data breach. And as I mentioned, the data is depressing because 46% of those we surveyed said that most organizations are extremely vulnerable to these types of attacks. And 45% said somewhat vulnerable. So 91% of those we surveyed said most organizations are vulnerable to attack. Well, if we're vulnerable to attacks, we obviously have to plan to mitigate risk. We have to do all we can to prevent attacks. But we also have to be able to respond to attacks and keep the business running. And once again, this really tees up Keith's presentation on network security and network resilience. So finally, we asked the ISSA panel to identify their top cybersecurity challenges, and these were the three most popular answers. So the first is 29% said the cybersecurity staff is understaffed for the size of my organization. And 28% said my organization depends on too many manual processes, manual and/or informal processes for cybersecurity. So think of those two in context with each other. I don't have enough people, they don't have the right skills, and they're bogged down doing manual processes, informal processes. That is not a good operational model. So we have to make things easier for them. We have to add intelligence. And in fact, every CISO I talk to, I mention to them, you won't have enough people to get what you want done, so think of how you're going to work around that. And we have to align those goals with network operations so that we automate processes, so that skills deficiencies don't get in our way. When we detect something, we can work with network operations to remediate things. Now, unfortunately, 24% of those we surveyed said business managers don't understand and/or support an appropriate level of cybersecurity. Well, this one, I just have to say, IT is the business these days. If you look at modern companies, digital transformation, IT is the underpinning. And so we have to understand that the business depends on IT, and IT depends on security, in this case network security, to keep it safe. And so we have to prioritize not only security, but how security aligns with the network and how that aligns with our business goals. In summary of all the data I've presented, we see a pretty scary situational analysis. So number one, security incidents and data breaches continue. We see that from the ISSA research. That disrupts the business. It's costly. It takes down our networks. It really impacts productivity. At the same time, the network is growing. It's more complex. There are more IT initiatives. We're moving workloads to the cloud. We have mobile workers off the network working remotely from all over the world. And this has a ramification on network security. It also makes the network that much more critical, a critical business asset that we have to protect and maintain availability and performance on. And of course, we have this staff and skills shortage. So we have to be smarter about what we do. We have to decrease the workload. We have to streamline operations. And we have to really instrument the network so that it is secure, we do reduce risk, and we do get the network performance and availability that we need for our business. I often use this slide. It's a very good way to look at things and look at the transition that we're in. This quote is attributed to Albert Einstein. There's some discussion or debate as to whether he said it, but the quote stands really, really well here. So what's the definition of insanity? Doing the same thing over and over again and expecting different results. Unfortunately, that's what we've done with IT security and network security in this case. We've layered on more complexity, more manual tasks. We don't have the right skills. We don't have the right staff size. So something has to change, and it has to change for the goodness of our business. And really, that's where I'll hand it off to Keith in a few slides. I think a good way to look at this is to align network resiliency with what I call the CISO triad. So these are the three tasks or three categories that a CISO is really responsible for. So number one at the top, security efficacy. This is about preventing cyber attacks from happening in the first place and understanding what those cyber attacks could be and doing everything you can to mitigate risk. Now that's typically where the industry, where a lot of security departments focus their attention, but there are two really other important components. So on the bottom right, operational efficiency. We know we don't have enough people. We know we have too much to do. What can we do to address those problems? So we have to automate our workloads. We have to figure out how to streamline our operations. We have to figure out how to work closer together between the security teams and the network operations teams. And so that's tantamount to success for a CISO these days because they are under-resourced. And then finally, and this is often ignored in our security discussions, but a CISO is responsible for business enablement. So I have to understand the mission of the business. I have to understand how we're going to execute to achieve that mission, and I have to understand every component of that business process, once again, to mitigate risk, to protect the company, and to understand how I will respond to some type of incident in a timely manner. So when you think of all those three things together, security efficacy, operational efficiency, and business enablement, that's why it's important to talk about network resiliency, because network resiliency supports all three of those goals. So to conclude my part of the presentation, the bigger truth is my summary and conclusion. Network security is not working. It's too complex, relies on too many tools and skills, too many manual processes. We do need to make changes. So some of the changes I suggest are CISOs need a holistic network security strategy that includes intelligent, modern, layered defenses. So defense in depth, but in a more modern, more integrated methodology. We have to improve threat prevention. And we have to do that without taking on massive types of projects. We have to enhance threat detection and response, reduce that 200 days to a manageable number where we can detect things quickly, investigate things quickly, prioritize remediation activities, and work with IT operations, network operations to do that remediation. That supports my next bullet, recover quickly from security incidents without disruption, or to minimize disruption. And then, of course, maintain availability and performance. So looking at network resiliency as security, availability, and performance. And that's really where we want to head. Thank you for listening. It was a pleasure to present today. And now let me turn it over to Keith, and I'll stick around for Q&A. So take it away, Keith.
Okay, thanks, John. At this point, I wanted to talk about a couple more data points. The research from ESG did a great job of exposing some of the issues with network security for enterprises. But in addition, here's a few more statistics that you might have seen or might not have seen. Security breaches are up 45%. In addition, 80% of cybersecurity experts expect a catastrophic data breach at their companies by 2021. And only 19% of businesses are confident that they can correctly recognize an attack in real time and stop any damage from being done. One of the biggest concerns to me is in the right-hand corner, though. The average time from intrusion to detection is 191 days, or a little over 6 months. Recent breaches like the Panera Bread Company that was breached for 8 months and Saks Fifth Avenue and Lord Taylor that was breached for around 1 year are clear examples of this issue. In addition, over half of victimized companies never discovered the breach themselves. That's right. A strong majority of businesses have to be informed by a third party, like the police or their customers, that they have been breached. Now that's a scary proposition. The second to last bullet is also an interesting one. Consider this. According to the Verizon DBIR report, almost 68% of breaches happen over the course of several days. Let me repeat that. Breaches happen over the course of days. It's not just a single-term incident, but often a long-term action. So a rapid response to security threats could help minimize the cost of a breach based upon this information. However, as I just mentioned, the average time for breach detection is 191 days. So this gives the intruder plenty of time to exfiltrate pretty much any data they want. So what if you could reduce the time from intrusion to detection to be less than 191 days? What if you could reduce that to 1 month, i.e. cut it to 1/6 of the time? Or maybe reduce it further to 1 week, or maybe just 1 day? What if you could go further? Would that be of interest to you? If so, that's what we're going to talk about. It's called network security resilience. First, what do we mean by resilience? Here is the standard definition from dictionary.com. You should get something similar if you visit the Webster's Dictionary site. Basically, resilience means the ability of an entity to return to its original form after being bent, stretched, or compressed. From our perspective, we are specifically talking about the ability of an IT network to recover to a normal, steady-state operations after a security attack and a breach have occurred. In short, you get attacked, defenses get breached, the network is compromised, the threat is discovered, the damage is fixed, and then the network is secure again. That's the process I'm talking about. Fundamentally, network security is not a case of if your company will be attacked, but when. And what can you do about it? By adopting a resilient security architecture approach, the time to observance and the time to remediation can be reduced. A resilient approach allows you to strengthen your capabilities to defend against attacks, maximize your ability to rebound from an attack, and minimize the severity and cost of security breaches. Now that we've gone over the concept, let's talk about some of the actions you can implement to make your network more resilient. First off, typical security defenses have focused on the following items: firewalls and basic access list restrictions, inline devices like IPS, WAFs, and SSL decryption, out-of-band security tools like DLPs, IDSs, and SIMs, and then penetration testing. These protection mechanisms are geared around network access and architecture vulnerabilities, and these are good things, but they are just individual components. The next question is, what architecture do you plan to implement? For instance, there are all sorts of components and policies you can implement, but to what end? If you look at the architecture in a simplistic way, you'll find that there are some basic categories. There are 3 common ones that I see. First is the best effort approach. Either the security engineer, executive, or someone else has said, we need to install some sort of level of security. This typically involves implementing firewalls and some basic security components, maybe some basic auditing and monitoring. The next rung up the ladder is regulatory compliance. This is often an executive level initiative. The thought is that business needs compel the company to be compliant to PCI, HIPAA, or some other standard. The further thought is that this should make the security architecture even more robust. Unfortunately, while compliance may be necessary for auditing purposes, it does not guarantee security. The third level is essentially the defensive approach. I'm going to make this network so secure that no one can break into it. This is when all those inline and out-of-band devices are deployed. You can even create defense-in-depth strategies for prevention. For instance, if someone gets through port 80 on the firewall, the next step is to challenge the data with DPI, or Deep Packet Inspection. There's other things you can do as well, like implement prevention, detection, and response processes. Unfortunately, these architectures all have at least one thing in common. They can and are being breached. Look at the stats we went over earlier and what John presented. Networks are being breached with no sign of a slowdown. Something else is needed. This is where security resilience comes into play. Here's a quick high-level chart to give you another view of the 4 different strategies and how they build upon each other. So first, you have best effort. This is the point solutions we talked about earlier for security products and some simple monitoring. Then you add regulatory compliance, which usually has some special logging and policy appliances and applications. Then you have the defensive approach. As I said earlier, this is where people often throw everything but the kitchen sink against the threats. This includes inline security appliances, SSL, TLS decryption, security device testing, etc. Network security resilience, then, is a set of activities that can be conducted to help the network after the breach happens. You can see some examples here. There should be considerable effort on finding indicators of compromise and data threat analysis in this set of activities. So to be clear, the best effort, compliance, and defensive strategies we talked about earlier are all focused on preventing a breach. The security resilience strategy is about after breach activities. The reason for focusing on this strategy is simple. You want to reduce cost. These activities, if done right, will help you reduce the costs of a breach, either directly by limiting the data stolen and/or by decreasing the amount of fines and bad publicity. Specifically, this strategy can help decrease the time to discovery of a breach, basically reduce the 6-month discovery time we talked about earlier to weeks or days. And then second, reduce data exfiltration. This will limit costs and fines, which are based upon the number of records stolen. So less records stolen means less liability and cost. So to be clear, we're not suggesting that you stop trying to prevent a breach. You always want to do that. What we're saying is you want to add another set of capabilities to lower your risk and the cost of a breach. At some point in time, you are going to be attacked. The question is, how painful and how expensive do you want that breach to be? At this point, I want to switch gears. I've focused on the security architecture so far. However, a best practice is to integrate network visibility with your security architecture, which yields significant benefits. Therefore, the next step is to create a visibility architecture. So what is this? A visibility architecture is simply a way to step back and take a holistic look at your network, organize your network monitoring strategy, and then integrate that strategy with other strategies like network security and troubleshooting. By creating a visibility architecture, and it's a fairly simple task, you can get a better understanding of what tools you have, where they access the network, and what data feeds into them. From there, you can optimize your monitoring strategy by pooling resources, load balancing data across tools, filtering out non-pertinent data to the tools, and integrating tools and data flows to eliminate problems faster than before. We've literally seen customers reduce their mean time to repair by up to 80% by creating a visibility architecture. There are 3 basic components to this visibility architecture: the access layer, the control layer, and the traditional monitoring tool layer. In the past, people have typically said that the security tools are the strategy, and so they didn't really need to plan out anything else. As a consequence, most enterprises have a mixture of all sorts of tools. Many they don't even use. A lot of unnecessary complexity, and then they still have a lot of network problems. Basically, the problems never magically disappeared. This is where a visibility architecture really helps. The first layer of the model is access. This is provided by some sort of network access device, whether it's a physical tap, a virtual tap, or mirrored port. In case everyone isn't completely familiar with taps and what they are, a traditional tap is a piece of hardware that you insert into the network. It makes a copy of all the packets, whether they're good or bad. This copy then can then be sent to monitoring equipment to be processed. Once the tap is inserted into the network, it's essentially set and forget. You normally don't have to do any programming to them. Taps are used for, quote, out-of-band monitoring, unquote, because the monitoring equipment is not directly in the flow of network traffic. The tap is, but all the equipment after that is simply receiving a copy of the traffic, and it's completely out of the traffic path for network traffic. You can connect or disconnect whatever equipment you want to the tap monitoring port, and it will not affect the rest of the network. A second type of network access is called a virtual tap, which is a software version of the hardware tap that you can use for VMware, KVM, Hyper-V, etc. environments. The virtual tap allows you to export monitoring data outside of the virtual environment to your security and monitoring tools in the physical data center. We'll come back to virtual taps later on. The third type of network access is called a bypass switch. Think of this as a special tap for monitoring tools that you insert directly into the flow of the network data. If you just inserted the tool and it failed completely, or you yanked the tool out, this would directly affect, i.e. stop the flow of data to the rest of the network. That's why we call it inline. Once a bypass tap is installed, connecting tools and monitoring equipment becomes more of a non-issue. The bypass tap adds in a failover protection capability so that network disruptions are minimized down to the millisecond level. This way, if the tool has a problem, or if you want to change tools out, the bypass functionality can be engaged so the bypass switch continues to pass all traffic directly downstream. Heartbeat signaling between the bypass switch and the tools ensures automatic failovers for tool failures. This provides maximum network uptime. A fourth type of access is called span ports, also called mirror ports, off of a network switch. While they make a mirrored copy of data, there are all sorts of issues with them, such as they require programming, they have security issues, and they only give summarized data, not a complete copy of all data. In fact, span ports themselves are one of the reasons you can develop network blind spots. The next layer uses a network packet broker, also called an NPB, which allows you to filter, aggregate, and load balance data. From a business point of view, there are several high-level benefits that packet brokers provide. This includes connectivity, reduced tool costs, scaling, reliability, and longevity. Packet brokers are designed to augment your monitoring tools, not replace them. In essence, they are a low-cost way to help turbocharge the efficiency and capability of your security and monitoring tools. There are different sizes and capabilities associated with packet brokers, and all packet brokers perform some sort of filtering, load balancing, aggregation, and advanced features like deduplication and filtering of layer 2 through 4 data. Some also provide application layer features like filtering, netflow generation, SSL decryption, data masking. The exact feature set really depends upon your needs. There are also packet brokers that offer specialized functions for inline or out-of-band deployments. For instance, an inline packet broker that's inserted between the bypass switch and the security tool can offer capabilities like high availability for mission-critical deployments, the serial chaining of security tools, load balancing of data to inline tools, and filtering of inline data to help improve the efficiency of your IPS tools. Out-of-band solutions can help optimize your out-of-band tools like a DLP or SIM or IDS. And for the third layer, after the packet broker layer, you've got this a set of monitoring tools. This is probably what most people are familiar with. Instead of receiving the data directly from a tap, these tools now receive filtered data that is more relevant and concise. This makes tools more efficient. If you want more details on visibility architecture or any of the components I just talked about, you can visit the IXIA website at www.ixiacom.com. Let's look at packet brokers a little closer. With a network tap, you get a complete copy of all of the raw data you intended to send to your tools. Unfortunately, from the tool perspective, this is like drinking from a street-level water main. There is lots of data coming at it very quickly that can overwhelm the monitoring and security tools. And your tools are limited to the fixed number of ingress ports that they have on the device. With the network packet broker, we introduce filtering. Basic packet brokers can do layer 2 through 4 filtering load balancing. This means we can filter on the source and destination IP address, port numbers, VLANs, etc., which minimizes the amount of traffic going to each monitoring tool. And that's definitely an improvement. It makes more efficient use of tool capacity and makes it easy to scale tools as needed. But this is still akin to drinking from a fire hydrant now for the tools. The volume is less than before, but it's still a lot. More advanced packet brokers can do additional capabilities. Most notably, they can perform deduplication of traffic to minimize the traffic a tool must process. They can also provide packet trimming to remove packet payload, and they can do protocol stripping so tools can analyze encapsulated traffic, like GTP, MPLS, and other tunneling protocols. And some even have deep buffering to provide burst protection for tools that operate at lower speeds. This all greatly reduces the traffic that the tools need to analyze. All of which makes the monitoring solution much more efficient. Now the flow of data is the size of a water pipe going into your house, and the tool can spend its maximum CPU capability processing relevant data, not on functions like deduplication. And then finally, ICSIA also provides a more advanced level of intelligence on our packet brokers. What I mean by this is that our packet brokers are able to process application intelligence, which lets the packet broker do true signature-based application identification and filtering, along with the correlation of metadata like geolocation, user device type, user browser type, and user browser type. This gives you more control over exactly what you want to monitor. And if your tools can't consume packet level data, the packet broker can generate NetFlow metadata. But we go beyond simple NetFlow and provide additional metadata that gives your tools very detailed contextual information. Now the flow of data is the size of a garden hose, which is extremely manageable. You now have the right amount of data going to the right tools. This is all very detailed information, but basically it means that your security and monitoring tools can now be much more intelligent, not just more efficient. The tools have access to data and intelligence in a way not possible with other visibility solutions. Next, I wanted to cover two common types of visibility solutions. The first is an out-of-band visibility solution. I thought I would show a basic picture to make it clearer. As you can see, the packet broker and tools are not in the flow of network traffic. The tap is, but nothing else is. Should the tools or the packet broker fail, there is no effect on network traffic, just your monitoring and security solutions. Here is a second visibility solution that we commonly refer to as inline visibility. Simply put, like I said earlier, this means that the tap, which is actually in this case called a bypass switch, sits between the packet broker and the tool. So the tap or the bypass switch is directly in the flow of the traffic, but the packet broker and the security tools are not. If any of those components fail, again the packet broker or the tools, the flow of data does not stop. If there is a problem, then the bypass switch can just fail over, and there's different redundancy options that you can program between the bypass switch and the packet broker, and also between the packet broker and the security tools. So there's actually multiple levels of failure that you can accommodate within the solution depending on what your needs are. Now that we've done a level set on the network architecture basics, let's get back to security resilience. Remediation and recovery from a breach is a big topic. We don't have time to go through the whole subject here, so what I want to focus on is how specifically the integration of a visibility architecture with your security architecture can help you. I have a list of 8 specific things you can implement. I'll go over a couple examples of some of these in a few minutes, but I'll introduce all 8 of the concepts here. One of the first things you want to do after a security attack is to find out whether your network has been compromised. One common approach is to buy a tool, like a SIM, DLP, something like that, that focuses on recognizing patterns and any oddball activity to uncover indicators of compromise. To do this, the tool needs network data fed to it by the packet broker. Besides a basic data feed, application intelligence can be used to look at the application level data. Basically, what applications are running on different portions of your network, how much data is flowing between different network segments, and the geolocation of users. This helps you in one of two ways. You can either directly see indicators of compromise, or the application data can be fed to your indicator of compromise tool. A second activity is to use a threat intelligence gateway. Threat intelligence gateways are typically a defensive approach to prevent infiltration, i.e. all incoming traffic from known IP addresses are dropped at the edge of the network. And that's all bad traffic, or all traffic coming in from all bad known IP addresses. However, if the IP address is not known as bad initially, packets and malware can infiltrate the network. If the threat is not captured by the IPS, it then continues into the network and does its dirty work. However, the threat intelligence gateway should have a constant update process with new access lists. This means that should malware get into the network, the threat intelligence gateway still has the possibility of catching outgoing traffic to newly discovered bad IP addresses and deleting that traffic before it is exfiltrated, i.e. before it leaves the network. In a third area, network packet brokers can be deployed in the out-of-band use case we spoke of before, and they have a couple of features that can also help with security resilience. One feature is SSL decryption. This allows the NPB to decrypt traffic and send it to an out-of-band monitoring tool like a DLP. Even if the traffic was decrypted and inspected initially as part of the defensive architecture and nothing was found, it could still contain malware, i.e. something got missed and it wasn't flagged, or you didn't have time to inspect all of the flagged bad traffic, which led to an actual security breach. At this point, the traffic may need to be subjected to deep packet inspection by an IDS or a DLP. Even if malware has already done its dirty work, you still need to understand how it works, where it came from, and how it operates. And then a well-built NPB should also be able to respond to commands from approved external devices through a REST interface. This allows you to automate responses to increase your response times, or I should say decrease your response times. This allows you to automate responses and maybe so in this case maybe a SIM sees some suspicious activity. With a RESTful connection to the NPB, the SIM can send commands to copy specific traffic based upon IP address, VLAN, port tag, etc., and send that traffic to an inspection tool, IDS, DLP, whatever, for further analysis. This automated capability delivers a phenomenal time to response to decrease time to resolution. Here is the second batch of possible capabilities to implement for security resilience. Cyber range training is another resilient type of activity. While this is general training rather than specific to resolving a single breach, this type of training provides IT and security personnel with tips and tools for performing forensic activities. Basically, it gives you experience in recognizing different categories of attacks so that during or after a breach, you can respond quickly with the knowledge of what to look for and where to discover indicators of compromise. Closely related to this is the use of security threat simulation tools to get a better look at how threats behave. For instance, once you have an idea of what you're looking for, you can run a simulation in a lab to see how the threat behaves. Specifically, let's say you think you're a victim of heartbleed. You can use a simulator to accurately depict how the piece of malware will behave and then look for telltale signs of it in your network. You know, like specific registered compromised, etc. Specific security threat simulation tools can also use rich NetFlow information from an NPB to essentially create a capture of relevant NetFlow-based information made during an attack. This allows you to get more specific data on the attack and how it took place. You can then replay that data in the lab to analyze the specifics of the threat. The last item is to install inline NPBs. A good defensive architecture should have these already. However, if they haven't been installed, you want them for a resilient approach. The NPB gives you the ability to quickly add or replace security tools with minimal to no impact to the network. For instance, maybe a firewall or IPS is damaged, i.e. contaminated by a piece of malware. If it's connected to a bypass switch or an inline NPB, then it can be rapidly replaced in the production network. The NPB can also facilitate the addition of a honeypot to study ongoing attacks, load balance to multiple concurrent tools, and the quick filtering of newly identified suspect traffic. This example covers how application intelligence can be used to help improve network security by exposing indicators of compromise. Packet brokers can perform filtering and other functions for application data, flow data, and metadata to provide a higher level of intelligence within your visibility architecture. This intelligence provides actionable insight that you can use to see macroscopic trends and indications of issues across your network. For example, I'm showing an example of some bad actor over in Eastern Europe performing unauthorized data exfiltration. The bad actor gets into your network and starts transferring files from a server in Dallas. Application intelligence can combine application information, bandwidth information, and geolocation information to show that someone in Eastern Europe has access to your server. They're using FTP to transfer that data to a location back to somewhere in Eastern Europe. So is this a problem? Well, that depends upon whether you have any authorized users in Eastern Europe or not. If not, I'd be investigating this ASAP. In any case, you have the information right in front of you. It's up to you what you do with it, and it doesn't take 6 months to discover this. It's actually closer to a few minutes if you're looking. This is just one example of how application intelligence can expose these indicators of compromise. This example shows an illustration of out-of-band SSL decryption. SSL decryption is often performed on an inline basis to inspect incoming traffic, which is a defensive technique like I mentioned earlier. However, once a breach has occurred, something was obviously missed. That suspect data needs to be decrypted again and deep packet inspection performed to isolate the threat and those details to determine what happened. Once the data is decrypted, it can be sent to the packet broker, which can distribute the data to multiple security tools like IDSs and DLPs. Well-designed NPBs allow IT engineers to selectively screen data based upon various criteria like the routing protocol, IP address, VLAN, application type, or other parameters. And that data is then fed to the security tools like a DLP or for deep packet inspection. The DLPs are used extensively to review suspect data and analyze it to make a determination and then pass that information on to other devices. In this last section, I want to sum things up with a review of some deployment options. The first thing to remember is that security is not a destination but a process, right? As I mentioned earlier, most networks are being breached or going to be breached, and a study from the Ponemon Institute, the 2018 study on global megatrends in cybersecurity, states that 80% of you expect that your networks will suffer a major attack and or breach during the next 3 years. However, you still need to do everything you can to protect your network and reduce the costs of a breach. To that end, where are you now with your network and security architectures? Where do they intersect? Have you included a visibility architecture? It's important because you can't protect against threats if you can't see them. Going back to our simple 4-stage model for security architecture, here are some specific activities that you should consider. Starting with best effort, Ixia works with a plethora of security device vendors that deliver security defenses like firewalls and out-of-band security tools. Ixia also has the right capabilities to provide you with out-of-band visibility, basically taps to capture the right data from key portions of your network, and then the ability to feed that data to a network packet broker where it can be aggregated, filtered, deduplicated, etc. to give you the right data that you need. Once you have basic capabilities and want to establish regulatory compliance, the data can be captured by the packet broker and can be fed to specific logging and compliance tools that you've already purchased.
Now, when you move to the defensive architecture, this is where you really want to plan things out. It's not going to be about deploying point solutions anymore, right? You'll need a well-planned architecture and set of processes to create the proper end-to-end architecture. One activity is to deploy inline tools. At the same time, you want cost-effective reliability for those tools, which comes from external bypass switches that have super fast failover times and heartbeat messaging. From the bypass switches to the tools and inline packet brokers. The last thing you want here is a self-inflicted outage. SSL decryption integrated into the packet broker lets you increase capabilities to your tools as well. If this feature is activated within a firewall, IPS or something like that, then it typically reduces the efficiency of those tools by 40 to 50% because the tool CPU now has to focus on non-core activities like the decryption and re-encryption of data. When you offload the decryption feature to a packet broker like the Ixia solution, the Ixia solution has enough processing capability that it can run at full line rate and not deprecate the standard feature set of the security tool. The defensive stage is also where you want to conduct resiliency testing of your security, like firewalls and IPSs. How well can they really withstand various malware and DDoS attacks? What's the actual throughput of your network and your type of traffic? A security threat simulation tool like the Ixia Breaking Point lets you create realistic traffic loads along with an extensive list of malware threat simulations to give you the dimensioning data you need for your security architecture. Breaking Point recreates every aspect of a realistic network, including scale and content, to validate the security posture of your network. Threat intelligence gateways are also useful at this stage to prevent the infiltration of malware from known bad IP addresses. Threat Armor from Ixia allows you to accomplish this task. By pre-filtering data from known bad IP addresses and traffic from untrusted countries, you can stop unwanted traffic from ever reaching the firewall. Blocking large volumes of traffic based upon IP address, location, and bad behavior enhances your security architecture performance and reduces your team's alert fatigue. Automatic system updates eliminate the need for manual updates of known bad IP addresses to the device's access list. This saves hours of configuration time over a firewall approach and means you don't have to worry about updating the CLI on your firewalls. Threat Armor does the blocking for you. While this function is similar to the data exfiltration blocking capability we talked about earlier, which is a resilient technique, blocking malware infiltration is a defensive technique. Ixia Solution Threat Armor detects infected systems to thwart outbound connections with botnet, phishing scams, and malware exploits. We then have the resilient architecture approach. So we've spoken at length about this, but Ixia makes solutions in this area, and we partner with other organizations to deliver the right solutions to accomplish your goals. Application monitoring is the star of this area for resilient architectures. With this technology, you can look for and investigate strange behaviors like potential indicators of compromise and policy violations. NPB automation is also supported within our products. And we also support cyber range training services that have been used extensively by multiple national and international organizations. And then, as mentioned earlier, Breaking Point can be used to simulate the malware. Besides the testing aspect that I mentioned earlier, you can also use it if you're trying to mimic a specific type of attack. WannaCry or something, and you want to see what directories and files it affects. You can use it alongside with another feature called Traffic Rewind to see how an attack happened and unfolded. This again helps you minimize the remediation time to make your system as resilient as possible and get you back to a normal state of operation as fast as possible.
This is my final slide. There are 2 white papers available on the network security resilience topic. You can download them through the console, or you can go to the URL listed here. Both of these documents provide more detail into what we've discussed. Thank you for your time.
Thank you so much, John and Keith, for walking us through how security resilience goes beyond the traditional defensive approach to your security architecture. Before we get into Q&A, I wanted to remind the audience of a couple of things. You could submit your questions using the Q&A button on your console. If we don't get to your question during today's event, we will answer them via email. I also wanted to remind you that we will send you the PowerPoint slides, event recording, and white paper this presentation was based on later this week. And I did see a lot of questions come through during the presentation, so I'm going to go ahead and jump in. John, this first question I believe is for you. What are the primary issues you are seeing with a defense in-depth architecture for network security?
I would say two primary things. One is that a traditional defense in-depth architecture has been kind of enterprise LAN focused, so perimeter defenses, internal network defenses. Today, a defense in-depth architecture has to extend to the cloud, to SaaS providers, and to mobile workers coming in on public networks. So that's number one. Number two is that traditionally defense in-depth architectures were composed of multiple individual boxes or appliances or even virtual workloads, things like firewalls and IDS, IPS and gateways and anti-malware systems, etc. And the lack of integration of those systems made security overbearing. So those systems have to integrate, they have to work together. We need kind of central command and control. We need some type of oversight for security operations. So those are the two things I'd say that I'm hearing the most about.
Great, thank you. This next question I believe is for Keith. Why is this, and I believe they mean security resilience, different than what other security companies and consultants are saying?
Okay, so the main difference I see is that most people are talking about preventing a security breach. And that's a good thing. You want to prevent as many breaches as possible. But as was shown earlier on the slides, the sad reality is that you probably won't be able to do so. So prevent what you can and make the emotional leap to, I'm going to get breached, how do I limit the damage as much as possible, fix the problem, and get back up and running as fast as possible. This is where I see the difference. Most people are stuck in trying to prevent the breach and not really paying enough attention to the other side of the equation. And that means higher and more unnecessary risk than they need to have.
Thank you. I believe this next one is for you as well, Keith. Is this solution complementary with other architectures and standards being talked about?
Yeah, so I would say yes. If you look at the NIST cybersecurity architecture, there are 5 levels of functionality that focus on prevention and remediation. So this lines up very well with that. HIPAA and PCI also place a huge value on preventing as much as possible of the release of personally identifiable information. Regardless of whether the network was breached or not, you want to limit the release of that information. So this is totally complementary to what is being said out there.
Nice, thank you. John, I believe these next couple questions are going to be for you. Does network security resilience introduce new requirements?
I think it not so much new requirements, but just better implementation of old requirements. I think Keith touched on that. There is a requirement for putting more thought into incident detection and response, but there's always been that requirement. I just think it becomes more formalized. You have to document processes. Those processes have to extend beyond security. I'd say the one requirement is really working collectively with IT operations, network operations, to define some common goals, define some common areas that you can work on together, do some breakdown of processes where one group would take the lead. But it's really a matter of making sure that the two groups work seamlessly together and that they can achieve common goals, which are preventing incidents, detecting them and responding, and keeping the network up and running as well as it can.
Nice. Next question for you, John. Can you provide examples of network resilience today?
Well, I mean, I can't cite any particular organizations because of non-disclosure, but I can tell you that organizations are very, at least leading organizations are very keen on understanding what the business ramifications are of different IT initiatives, and then understanding the business processes underneath them, and then doing all they can to understand what the risks are associated with those business processes, doing tabletop exercises to do threat modeling, to understand what would happen if there were an incident, and then to engineer around that incident for the kinds of benefits that we talked about with network resiliency. So minimizing downtime, maximizing performance, minimizing business disruption. That's a pretty standard kind of model, but achieving it's a little bit more difficult, and I think it really does take some proactivity and some forethought to do so.
Great, thank you. And I still see a number of questions coming in from the audience. I think we have time for one more, but don't be discouraged. If you have a question, please submit it, and we will respond to those via email after this event. So last question for Keith. You talked about applications, intelligence, and exposing indicators of compromise. Can you give an example?
Yeah, sure. Basically, what I was saying is that you can use information about the types of applications running on your network, along with the geographic flow of information, to identify aberrant behavior. For instance, say there's someone in Eastern Europe connecting into your network and using an FTP server in Dallas, Texas. We all know that FTP is the file transfer protocol for IP traffic. If they are transferring data from the FTP server back to that location in Eastern Europe, and you have no authorized users in that part of the world, that is probably something you want to look into. I definitely would. While most people think that improving network security is some sort of black magic, and some parts of it can be really complicated, a big part of the issue with network security is just getting access to the data you need when you need it. In this case, once you can visualize the problem, it's a lot easier to investigate it and then either allow it, if it's okay, or terminate the user's connection if there is a problem.
Lots of great questions from our audience. Thank you so much, Keith and John, for answering them. And a big thank you to our audience for your interest and participation in this event. A reminder that if we do not get to your question, we will answer it by email after the event. If you want more information about Ixia solutions, please visit our website at www.ixiacom.com to contact us or visit the link shared in this presentation. We hope you will join us at future events. You could visit the link that's on your screen to see upcoming events for Keysight and Ixia. And I just want to thank you again for joining us. We really appreciate your participation, and we hope you have a great